So we are finally getting into applications of the derivative, and before we get into really big word problems, we need to understand this concept of implicit differentiation. So I would encourage you to read all of this. I'm going to try and summarize it. But if we have an explicit function, the key word that I'm using there is it is a function. So what that means is that there's only one y value for each x value. The problem is not everything that we're going to look at this year is going to be a function. I believe it has up until this point, although we could have looked at things with the limits as not being a function. I just don't think we did. Okay, so the issue that we have is if I really wanted a circle, by the way, this is a circle. I'm just assuming that you could recognize that would be a circle. Technically, this top one is a semicircle. The bottom one is a circle because if you were to have a positive 5 and negative 5 for x, it would be 25 minus 25, so that would be 0. And if you put in 0 into this, you would get a positive. And the reason why so that's why the top one is just a semicircle, because then the bottom one, we want the negative values as well, so it would go below the x-axis. And every one of these points has a tangent line, and you should have learned about tangent lines in geometry. And what I'm going to do next, I'm going to skip ahead. Again, you should read all of this. It's all good information. But if you were asked to differentiate this problem before, using the chain rule, you'd probably rewrite it like this. So then the derivative, and I also prefer this notation instead of f prime. It'll make more sense when I get over here. You bring the 1/2 in front, you leave that 25 minus x squared alone. Now it's to the negative 1/2 power times the derivative of the inside, which would be negative 2x. And from there, I don't know if you would actually think about doing this, but this part you would. Half of 2 would cancel. But this is actually equal to negative x over the square root, because of the negative exponent, square root because it's the 1/2 power, 25 minus x squared. I guess I should rephrase itself. I think you would do that. I don't know if you would do the next thing, which is recognizing that the denominator was defined as being y. So what I can do is I could simplify this as, I can't change that negative x, but I can change the denominator because it's equal to y as y. So this is your derivative. So I'm going to teach you a new method, and it's still technically the chain rule. Because when we're doing things implicitly, we need to have an independent variable. Well, we like to leave x as your independent variable. So if I ask you for the derivative of x squared, it is 2x. But now when I ask you for the derivative of y, that is not your independent variable. So what you need to do is take the derivative of it, which is still 2y, but then you have to tell the reader, okay, well, y was my dependent variable, so I need to, basically, the chain rule, take the derivative of that piece. You didn't have to do that with x. I guess technically if you wanted to, I'm going to write it and then I'll erase it, is you could write 2x dx to let the reader know that that's your independent variable. Well, anything over itself is just 1. You can think of it that way. That might help some of you understand why you have it for dy but not for dx. Or you could just accept that it's true. I think when I was in high school, I just accepted that to be true and I moved on with life. And be careful here, because 25 is a constant, while the derivative of a constant is 0. So now if I'm asking you to solve for dy dx, what you would want to do is subtract the 2x over, and then divide by 2y. Well, what do you notice? is the 2's cancel out and you're left with negative x over y. And it makes the math a lot easier if you understand implicit. And you have to understand it because there's problems that can only be done implicitly. And again, we use implicit when it is not a function. And that's exactly what the next page is going to show you. Not a function. And you can see I'm going to ask for several derivatives along these points. Okay, so just giving you a heads up. You probably remember from pre-calculus. If you don't, I'm going to write it out for you. Is you want to identify the center of the circle, which I would look at like the top and the bottom and the furthest to the left and furthest to the right, and see where they all meet in the middle. So then you could rewrite that as x minus 3 squared plus, remember minus shifts it to the right, and then y plus 2, that shifts it down, is equal to the radius, which from the center would be 1, 2, 3, 4, 5 squared. And if anybody needs a reminder, here's your reminder from pre-calculus. X minus h squared plus y minus k squared equals r squared, where the center is at hk and r stands for radius. Okay, so if I were doing this problem, I would not FOIL that out. That's just my opinion. I would do this as if I was doing the chain rule, where the derivative of the left side would be 2x, sorry, I wrote that wrong, 2x minus 3 now to the first power times the derivative of the inside would just be 1. And then same thing with the next one. 2, it's y plus 2 now to the first power, and then times dy dx is equal to 0. So again, you don't have to do the problem this way. It's just how I would do it because I can already see what the final answer is for dy dx, which you would subtract the 2 times x minus 3 over, and then divide by the 2 y plus 2. And notice I didn't write the 2's. I'll go ahead and write the 2's in there because they'll cancel each other out. The only reason why I'm writing them in now is because I would actually probably distribute that negative in there so I don't forget. So why do we have this? Is the derivative depends on which y value we're looking at. So as we look at this ordered pair 0, 2, and they're asking you for dy, by the way, this is the notation, dy dx at the ordered pair 0, 2. We put just a line there to say, hey, it's this point for this equation. You can plug in 0 for x, which will just give me 3. Plug in 2 for y. I hope you understand where I'm getting all that. And so what that tells me is that 0, 2, right here, its tangent line goes up 3, right 4. And also down 3, left 4. So as I connect these dots, I hope you would agree that that was a perfect tangent line. Oops, went down too far. Let me just change colors to make this a little bit nicer. So again, I want you to practice the notation dy dx at the ordered pair 3, 3. So as you plug in 3 for these x's, x and y, so negative 3 plus 3 would give me 0. Well, 0 divided by 5 is still 0. I guess I could write that in. So as I look at the ordered pair 3, 3, that slope is 0, so that's a horizontal tangent line. So let me just ask the question a little bit differently. Where else would I have a horizontal tangent line? You can pause and try to figure that out. You could probably finish the table if you wanted to figure it out. But as I'm looking at, the other horizontal tangent line would be down here. And you can verify that because if you plug in 3 for x and negative 7 for y, this will give you 0. Let me change colors and just do another one. 8, negative 2. Or you can make a conjecture. What do you think is going to happen at 8, negative 2 for the tangent line? If you're not sure, go ahead and work it out. So dy dx at 8, negative 2. In this case would be negative 8 plus 3 would be negative 5. Negative 2 plus 2 is 0. And that is your clue that this is an undefined slope. Now, I would hesitate to say that this is a vertical tangent. But, and the only reason why I hesitate is you might have a problem down the road where you're dividing by 0, which just means the derivative does not exist. But in a circle problem like this, that's your clue that it's a vertical tangent line. And some of you might be thinking that. Yeah, that's a vertical tangent line there. So again, think of another place that might have a vertical tangent. If you're thinking over here, then you were right. So that's at negative 2, negative 2. I don't know what the number is. It's something divided by 0. I'll just put c divided by 0 because I don't know what that c is. And you can figure that out. It's undefined, which is your clue that it is a vertical tangent. And I think we've done enough to verify, but I'm going to share with you the answer key. So if you want to work this out on your own, go ahead and hit pause. Next thing you'll see is the answer key. So again, notice the notation. Notice that everything works out. And they are perfect tangent lines. So hit pause if you still need to copy anything down. Otherwise, I'm going back to the notes. And I think I'll get through a couple of these problems. I definitely need a second video to do this. So just make sure you remember all of your rules when you're doing implicitly defined functions. So as I look at this, the left side, the derivative of y squared would be 2y, but you have to say dy dx. On the right side, the derivative of 2x is just 2. If it helps, you could write dx dx, your independent variable, but those will cancel, so you don't have to. Plus 3 dy dx. You have to tell the reader that you understood that you took the derivative of y here. So I'm going to really celebrate this next step. As you get better, I anticipate you guys not showing this step. Because in order to solve for dy dx, you have to get the same, you have to get dy dx is on the left side or the right side, just on the same side, and everything else on the other side. So then you can greatest common factor out the dy dx. And now it just looks like a multiplication problem. Well, how do you solve a multiplication problem? So we're solving for dy dx is with division. Perfect. That is your answer. I think I can do the next one in my time limit. So I'm going to go for it. Derivative of the left side. Don't forget the derivative of e to the y is e to the y, but you have to say dy dx is equal to 2x minus 2y dy dx. So again, I'm really going to celebrate this next step. Oops, I was supposed to say e to the y. That's what happens when I'm in a hurry. And then I end up not finishing it in time. Dy dx, I would add the 2y dy dx to the left side. Subtract 2 to the right side. No need to factor things out. I'm talking about this as a GCF. You do need to factor out your dy dx. E to the y plus 2y is equal to, I mean, if you want to, you could factor it out, but it's not necessary. Let's say you had 2e to the y plus 2y, then yeah, you could factor out a 2 and divide everything. But it's not necessary here. So our final answer is 2x minus 2 over e to the y plus 2y, because again, I divided. Alright, so I need to end the video here. I'm out of time, and I will see you in the next one.